So welcome to the day one of a new topic, that is number sense and algebra. So in today's class we are going to start with a new understanding, that is exponents. So let's first just dive into the topic and understand the basics of it. So just have a look at this now. So this is the heading now. So we are now going to understand laws of exponents. So just ignore the name for a second. Just understand this basic sense. Let's say there is a number a. There is some number a. So if I multiply this a with another a, that would actually give me a square. A square. A raised to the power of 2. So this 2 over here, is actually the exponent of this base a. So this entire chapter is actually based upon these powers, the powers which are there. So if I am multiplying an a with another a, I am getting a square, which means that a is being multiplied 2 times. So similarly, if let's say if I am multiplying 3 a's, a with another a with another a, it would give me a raised to the power of 3. A raised to the power of 3. So this 3 over here is the exponent on this base a. Let's say if you have one apple. Let's say you have one apple, which is, let's say it is denoted by a, and I add one more apple to it, so it becomes 2 apples. This is different than this. When I'm multiplying one a with another a, is same like when I'm multiplying 5 with another 5. It gives me 25, which is actually 5 square. Or if I do 5 multiplied with 5 multiplied with 5, it is actually 5 cube. So can we directly see first of all that 2a is not same as a square. 2a means that we have simply added 2 a's, we have simply added a number twice. And a square means that we have multiplied that number twice. A cube means we have multiplied that number thrice. Similarly, if I just extend this logic, so the sense is this, that a raised to the power m actually means, where m stands for, let's say, any integer. I'm just talking about any integer right now, and we know that what is the meaning of an integer actually is. Integers are numbers which are complete numbers, minus 0, then minus 1, minus 2, and so on the back, and 1, 2, 3, and so on the positive side. So these are integers. So if a raised to the power m is written, we know that it means that a is being multiplied m times. So this is the sense, that we are simply multiplying these a's m times. So this is the sense when we write a raised to the power of m. So can we now interpret this logic? Then when a raised to the power m is multiplied with a raised to the power of n, it means what? With the same understanding, can we say that it means that we have multiplied a m times, and then we have further multiplied a n times. So in all, how many times a has been multiplied? So can we directly say that a has been multiplied in a way m plus n times? Let's say this is the logic now. So this is something which is actually our first law of exponent, and this is something which we'll always keep in our mind from now onwards. So just write this somewhere, because this is the first law which we have to use in every other question. So it is very basic. We know that from now onwards that a raised to the power m multiplied by a raised to the power of n means same base and different powers when they are multiplying. So these powers simply get added. So it means what? 2 raised to the power of 3 multiplied by 2 raised to the power of 7 is directly same as 2 raised to the power of 3 plus 7, which means 2 to the power of 10. So this is the sense. This is our first law, which we can even interpret ourselves. We can directly judge that a raised to the power m means a is being multiplied m times, and then we are further multiplying those a's n times more. So in a way, if we just count how many times these a's are being multiplied, we can directly judge that the number of times is actually m plus n, and that is something which we have written. But we are not going to create such story every time. We'll directly use this as our first formula. So this is the first understanding which we'll just keep in our mind from now onwards. So this is the first very important thought right now. So this is the first law. So similarly, this is the second law now. Second law is this, that a raised to the power of m whole raised to the power of n is same as a to the power of m multiplied by n. So this means what? That let's say we have written 2 to the power of 3 and this whole is raised to the power of 5. 2 to the power of 3, this whole term raised to the power of 5 now. So this is same as 2 to the power of 3 multiplied by 5, that is 15. This is our second understanding. This is our second understanding, which is actually, if you notice, this is just a continuation of this process only, but nobody is going to ask us to prove this. But we are going to apply this sense in so many questions. So just note down this as well. So this was our first law, a to the power m multiplied by a to the power n gives me a to the power m plus n, and this is the second law. A to the power m whole to the power n is equal to a to the power of m multiplied by n. And this is its application. So this is the second law.